Hello students, let us solve a syllogism question, an interesting question. See the statements. Only a few grain are vegetables, some vegetables are not bean, only bean are nuts, few green are colors. These are the statements given and we need to verify these conclusions. Conclusion number 1, some nut is not vegetable. All color can be vegetable. Some green are not bean. All being vegetable is a possibility. Okay, so to solve this question, let us see some basic. Okay, let us learn qualifiers like only few, only, and some not. A few. Okay, few, some not. Few is nothing but some only. Some not, only, and only few. First we'll see these, the basic behind background concept for these four qualifiers, and then we'll enter into the question. Okay, firstly, few is nothing but some only. Okay, some A R B. So for this, the basic diagram, the minimum overlapping diagram is this one. Some A R B. Next is only A or B. Suppose if the statement is only A or B, only A or B, if this is the statement, so first of all let us understand this statement. Only A or B means other than A, no other thing can be B. Okay, except A, no other thing can be B. Means B should not have intersection with any other circle except A, right? So how to draw the diagram then? We can draw in this way. Let us keep complete B inside A. Complete B is inside A. B is inside A. So if any circle comes, it can intersect with A only, but it should not intersect with B. But if you leave our diagram like this only, it is the same diagram for all B or A, right? So to avoid the overlapping of B with any other circle, let us make a fence over B so that no other circle enters into B other than A, right? So only A or B, no other thing is B, right? So this is the fence over B so that no circle enters into B. This is the basic diagram for only. Okay. Next qualifier, only a few green are vegetable. Only few. Let us see only few. Only a few A or B. Only a few A or B means not all A or B. Only a few A or B means not all, right? So few means some must be there, some overlapping must be there. Means this is some overlapping A and B. So if you leave the diagram like this, A can completely go inside B and B can completely come inside A in some other possibilities. But it is given only some part must be B, not all the part. To avoid complete overlapping of A inside B, let us do this one. Let us reserve some space in A. This part can never be B anytime. Rest of the part can be. Okay. So this part of A cannot be B. Now see, few A or B, but only few A or B, not all A or B. This part can never coming under this. So this is the basic diagram for only a few. Right. Next is some not. So for some not, the diagram, basic diagram is some A not B. If this is the statement, some A not B. Some A not B means this is A and this is B. This is A and this is B. If you take some part of A if you take some part of A, it cannot come inside B. Rest of A can come under B. Sum A not B means remaining A can be B. Only sum A cannot be B. Right. So this is the basic diagram for sum not. Okay. So this is sum only a few, sum not. We already know all and no. All A are B. For this one, the basic diagram is complete A inside B. No A is B. For this one, the basic diagram is no intersection must be there. So to avoid intersection between A and B, let us make a constraint like this. A can never intersect with B. So these are the basic diagrams for all the qualifiers we have. Some, all, no, only a few, and some not. Right. So using these basic diagrams, let us make the common Venn diagram, common basic diagram for all the statements together. Right. Only a few green are vegetable. Only few green are vegetable means few green are vegetable, as well as few green can never be vegetable. Okay, few green are vegetable and few green can never be vegetable. Next, some vegetable are not bean. Some vegetable are not bean. This is bean. And if you take some part of vegetable, this part of vegetable can never coming under beans. Remaining part of vegetable can come under beans in some possibilities. Next, only bean or nuts. So only bean or nuts is nothing but all nuts are bean and nuts should not intersect with any other circle. Means a fence over nuts. So complete nut circle should be inside bean circle and there must be a fence. There must be a fence over nuts so that no other circle can intersect with nut except beans. And lastly, few green are colors. Few is nothing but some green are colors. Some green are color. This is color. So finally, this is the basic diagram. This is the basic diagram of the given statements. Now we'll verify the conclusions. First conclusion: some nut is not vegetable. Some nut is not vegetable. See, nut is here and it is given vegetable. See, just by saying the statement itself we can say the answer. Nut is not having intersection with any other circle except bean circle. It is given some nut is not vegetable. Yes, it is 100% true because nut cannot be any other, even vegetable, color or green, any other except bean. Right. So see the fence over nut. No circle intersect with nut. That's why, and he is also saying the same thing. That's why it is true always. Next, all color can be vegetable. So can be means it is a possible conclusion. Possible conclusion. All color can be vegetable. Can we place complete color inside vegetable? What if I keep complete color inside vegetable? Right? Is it making any disturbance in the statements? No, it is not making any disturbance in the statements. Means is it a possibility or not? Yes, it is a possibility. Right. It may not be in basic diagram, but somewhere it is possible. And even here also it is asking for possible only, not 100%. Right. Coming to the third conclusion. Some green are not bean. It is a definite conclusion. These two are the this is a possible conclusion and this is a definite conclusion and this is a definite conclusion again. Some green are not bean. Some green are not bean. Some green are not bean. Is there any portion of green that cannot be placed inside bean? Is there any portion of green that cannot be placed inside bean? No, because we can keep complete green inside bean circle. But he is saying some green are not bean. In this possibility, in which green completely comes inside beans, In that possibility, this is fail. At least one possibility fail means total fail only. It is not 100%. It may be a possibility, but it is not 100%. Means it is not a definite conclusion. Next. All being vegetable is a possibility. All being vegetable is a possibility. He is saying complete bean we can place inside vegetable. Complete bean we can place inside vegetable. Is it correct? Is it making any disturbance in the statements? Yes, it is making, because of nuts. So if you bring beans into vegetables, nuts will also come along with the vegetable bean. So that will overlap with vegetable, which is a violation of the given statements. So that's why it is not at all a possibility. So all being vegetable is a possibility? No, it is not a possibility. So the final answer is only conclusion 1 and 2 fall. Right. Thank you.